Thin ice filmed the water bucket inside a half-finished cabin at dawn. The stove sat on the ground outside because the walls weren't high enough to support the chimney flashing. Signal service records from Fort Ellis, 60 miles northeast, showed the first killing frost had already arrived at the lower elevations. Up here, between 6,500 and 7,500 feet, building season was measured in days, not weeks. Most ranch crews assumed corner notching would take 5 to 7 days for a 16 by 20 cabin, time they no longer had. Yet scattered in preservation reports and old ranch ledgers are notes describing full-sized log structures raised to 9 courses in 3 working days, with tight half-dovetail corners and almost no later rework. The difference wasn't strength or luck. It was a scrap board with a trapezoidal hole cut in it, a wasteboard jig that turned geometry into wood. The coarse frost on unshingled rafters told the story without words. By the 1st of October, 1886, the high basins of Montana Territory had already surrendered their above-freezing nights. A water bucket left inside an unfinished cabin showed a skim of ice by dawn, even though the site sat in full sun by mid-morning. This wasn't unusual weather. Early Weather Bureau summaries and Signal Service tables from Fort Ellis and Fort Custer documented mean winter temperatures and first frost dates across the northern Rockies. In the Gallatin Valley and adjoining mountain country, settlers could expect hard freezes by late September or early October. Snow was possible any time after that, and once deep snow arrived, wall work stopped. The narrow window between harvest and freeze controlled everything. Ranch hands finished haying in August or early September. Cattle needed to be gathered, sorted, and shipped before the rails became unreliable. Freight wagons made their final runs from railheads like Bozeman or Livingston, 40 to 60 miles of rutted road before weather turned. And somewhere in that compressed schedule, someone had to raise walls. A typical high country cabin measured 14 to 18 feet by 16 to 24 feet. Walls required 8 to 10 courses of logs, each log 9 to 12 inches in diameter. Corner systems varied by region and builder experience. Saddle notches, V-notches, half-dovetails, with square notches reserved for sheds and rough outbuildings. The tools were standard: felling axe, broad axe, crosscut saw, adze, dividers, plumb board, log dogs, and auger. Every item had to be hauled in, maintained, and used efficiently. Time wasn't measured in hours, but in days of clear weather, dry wood, and available hands. Most settlers planned on a few days for walls. Field practice told a different story. A 16 by 20 cabin with 9 courses meant 36 corner notches, 18 logs, each notched at both ends. Contemporary log building and preservation manuals explained that each notch pair took 30 to 40 minutes when cut by eye with repeated test fits. That was 18 to 24 hours of pure notching time, spread across multiple days because logs had to be wrestled onto the wall, marked, rolled back down for cutting, and lifted again for testing. On paper, 18 to 24 hours looked manageable. In reality, short daylight, cold hands, and the physical toll of lifting 12-inch logs 6 or 8 times per corner turned manageable into grueling. Corners alone consumed 5 to 7 days for most crews, and corners had to come first. Until walls reached full height, rafters couldn't be set. Without rafters, no roof. Without a roof, the interior stayed soaked from rain or snow. Floors couldn't be laid. The stove couldn't be installed safely. Every delay at the corners cascaded forward. Ranch bookkeepers tracking hay deliveries, freight costs, and day wages understood the math better than anyone. A crew burning a week on corners left less time for cutting winter fuel, repairing stock shelter, and securing provisions before the first serious storm. In a climate where winter could arrive with 48 hours' notice, lost time was a direct threat to survival. Yet some structures went up faster. National Park Service briefs and Forest Service preservation reports occasionally noted cabins raised in a few days or completed quickly before snow. These weren't shacks. They were full-size, well-built structures with tight dovetail corners and straight walls that still stood a century later. The question wasn't whether it was possible. The records proved it was. The question was how. A rail timetable hung on the wall of a ranch house near the Bozeman Depot, next to a rough calendar marked with shipping dates and the words cabin work penciled in a narrow band of days. The timetable listed train arrivals and departures, but the real information was in the gaps. How many days a ranch could count on between freight deliveries. Between mid-September and mid-October of any given year in the 1880s and 90s, the Absaroka and Gallatin ranges experienced a compressed building season that defied optimism. Weather Bureau records and later USDA climate summaries documented first frost dates, typical snow onset at elevation, and the number of workable days remaining after haying and before deep snow made high country access difficult or impossible. The railroad was the lifeline. Hardware, kerosene, salt, flour, and any tool that couldn't be made locally came by rail to depots like Bozeman, then by wagon to remote ranches. A round trip from a ranch to the railhead and back could consume 2 full days, 1 day out, 1 day back, with loading time in between. Every trip pulled a team and a driver away from other work. Supply lines stretched 40 to 60 wagon miles in good weather. In bad weather, or once roads turned to mud or snow, they might as well have been 400 miles. Ranchers learned to consolidate freight runs and time them carefully. Miss the window, and critical supplies wouldn't arrive until spring thaw. Labor allocation added another layer of constraint. The same men who raised walls were needed for hay, fencing, and shipping cattle. Ranch bookkeepers kept ledgers tracking every task. Bales of hay moved, fence posts set, head of cattle shipped, days of labor paid. Every entry represented a choice. Time spent on one job was time unavailable for another. A telegrapher at the Bozeman Depot tracked freight arrivals and weather delays. A ranch bookkeeper recorded when wagons left for town and what they brought back. Both understood that schedules existed only on paper. Reality was weather, breakdowns, sick animals, and the relentless pressure of approaching winter. With only a handful of fair days between the last hay and the first serious storm, any method that shortened one critical task created room for another. If corner notching dropped from a week-long bottleneck to 2 or 3 days, those saved days could go toward fuel, stock shelter, or simply finishing the roof before snow arrived. The timetable on the wall listed trains and cattle shipments, but the real deadline, the one that couldn't be negotiated or postponed, was how many corner notches could be cut before the first storm buried the worksite under 2 feet of snow. A log lay on sawhorses, its bark marked with chalk scuffs, where a builder had traced high spots by eye, trying to visualize where the notch should go. The marks wandered slightly, corrections layered over earlier attempts. This was standard practice, mark by sight, cut, test, adjust, cut again. Between 1870 and 1900, from Dakota homesteads to northern Rockies ranger stations, most log cabins rose through a process that looked deceptively simple but was brutally inefficient. Manuals described clean geometry and precise joints. Real cabins showed gouges, shims, and patched corners from iterative guesswork. A Norwegian homesteader in a timbered draw worked alone, rolling each log into position multiple times. An early forest ranger overseeing seasonal cabins watched crews repeat the same mistakes, cabin after cabin, because no one had written down a better way. The standard corner workflow proceeded in painful stages. Roll log into place on the wall. Eyeball where it crossed the lower course. Rough mark the notch with hatchet or chalk. Roll the log back down. Chop or saw the notch. Roll the log back up. Test the fit. Roll it down again for corrections. Repeat until acceptable. Each log was fully lifted 4 to 6 times before final placement. For a 12-inch log 16 feet long, each lift required 2 or 3 men and significant effort. Multiply that by 36 corner notches, and the physical toll became crushing. The process relied heavily on the builder's eye rather than fixed reference. A tired crew made more errors. A less experienced hand cut notches too deep or too shallow. Cold weather made fine adjustments harder. Each small error compounded, walls twisted out of plumb, corners opened gaps, and doors bound in their frames as logs settled unevenly. Early 20th century log building handbooks, drawing from earlier practice, referenced scribes, dividers, and plumb boards. They described dovetail geometry and explained why certain notch types shed water better or locked more securely. But they never mentioned dedicated corner jigs or systematic templates. The assumption was that skilled hands and good judgment were enough. Homesteader diaries and ranger reports occasionally mentioned cold at the corners or walls drawing out of true. Preservation surveys documented the results. Cabins with persistent chinking failures, racked frames, and out-of-square door openings. These weren't signs of lazy work. They were the natural outcome of cutting complex geometry by eye under difficult conditions. Even skilled workers lost time to rehandling. At conventional rates, a 3-man crew could burn most of a frost window simply correcting the same mistakes, log after log. Yet some structures of the same size were recorded as raised in 3 days. The difference had to be method, not muscle. An archival photograph showed a completed log cabin, walls straight and tight, with a handwritten caption noting it had been built in the fall of year in a few days. The cabin featured half-dovetail corners that building literature consistently called slow and fussy. Between 1880 and 1930, scattered across the Appalachians and northern Rockies, preservation architects began documenting structures that didn't match the conventional timeline. The Avent cabin in Tennessee, a 16 by 23.5-foot structure with half-dovetail notched poplar logs, was one example. The Triangle X barn in Wyoming was another, its lower courses built from a neighbor's unfinished dovetail cabin, its upper courses square-notched, showing both mixed practice and material reuse. These weren't crude shelters. Surveys revealed careful log selection, consistent notch geometry, and minimal evidence of later shimming or rework. Descendants quoted in preservation reports recalled family stories about how quickly grandfather's cabin went up, sometimes before the snow or in a few days. The technical contradiction was stark. Forest Service guides and log building manuals emphasized that dovetail corners required precision and patience. Each notch had to be cut with a specific taper, narrower at the inside face, wider at the outside, to create the self-locking wedge that kept corners tight as logs settled. This geometry was superior to saddle or V-notches for shedding water and preventing twist, but it demanded more layout time and more careful cutting. Yet the field evidence suggested otherwise. Cabins with full dovetail corners and footprints comparable to slow-built. Structures showed up in records with remarkably short construction windows. If the crews were using the same notch pattern and the same tools, axes, saws, scribes, but working in half the expected time, the variable had to be process, not geometry. Preservation reports provided the dimensions and notch angles. Oral histories provided the timelines. What was missing was the step-by-step description of how layout happened. The manuals explained what a dovetail notch looked like. They didn't explain how a crew marked 36 of them quickly and uniformly under field conditions. The corners in the photographs looked like classic half-dovetails, 4-inch depth, consistent taper, clean bearing surfaces. But the schedule read like a rough line shack thrown up in a weekend. Something was missing from the standard explanation. A story stick leaned in the corner of a cabinet shop, its edge covered with knife notches marking window heights, sill depths, and trim reveals for an entire house. Each mark represented a measurement that would be used dozens of times. The stick eliminated repeated measuring and reduced errors. Between 1820 and 1900, in cabinet shops, mills, and framing crews across the eastern and midwestern United States, carpenters operated within a highly systematized craft tradition. Log cabins were remembered as rough work built by self-taught frontiersmen with axes and determination. But many of those frontiersmen had worked in mills, framed barns, or trained in shops where pattern boards and templates were standard practice. A sash and door mill worker used pattern boards, thin templates, for repeated parts like stair carriages, window rails, and door panels. A barn framer laid out complex mortise and tenon joints from a single layout stick that held all the critical dimensions. Shop practice included stops and fences on saws and planes to lock reference faces, ensuring that dozens of identical pieces could be produced by semi-skilled workers with minimal error. 19th-century carpentry manuals illustrated story poles and templates in detail. Trade journals published comments on error reduction and speed gains from standardized layout. The logic was straightforward: measure and mark once, cut many times. Let a piece of wood hold the geometry so hands could focus on execution rather than layout. This mental toolkit didn't stay in town. Carpenters and mill workers migrated west for opportunity. Some became ranchers, some worked on railroad construction crews. Some ended up in remote valleys raising cabins for seasonal work or homesteads. They carried their training with them. Once you were used to a board holding the geometry, hand-scribing each log individually seemed wasteful. If pattern boards kept hundreds of window sashes identical in a mill, the same principle could keep dozens of corner notches uniform in the backcountry. The cultural gap between craft carpentry and frontier log work was more permeable than folklore suggested. The tools differed: planes and chisels in town, axes and adzes in the mountains. But the underlying logic of jigs, stops, and patterns translated directly. A carpenter who had laid out 100 mortises using a story stick would recognize immediately that corner notches were a repetition problem, not a craftsmanship test. In town, pattern boards kept production fast and consistent. In the backcountry, the same logic could turn a week-long corner ordeal into a 3-day raise. A weathered plank lay in a wagon bed alongside axes and saws. At first glance, it looked like scrap: 8 to 10 inches wide, 24 to 30 inches long, 3/4 to 1 inch thick, with a trapezoidal hole cut through the middle and a few blocks nailed along one edge. To a casual observer, it was trash. To a builder trained in shop practice, it was a portable layout machine. Between 1880 and 1910, in high country building camps across Montana and Wyoming, a small number of builders, often men who had worked in sawmills or carpentry shops before moving west, began adapting pattern board logic to log corners. The result was what later manuals would call a wasteboard jig. The plausible design was simple. Start with a straight, dry board. Cut a dovetail opening sized for the logs you're working with. For 9 to 12-inch logs, a notch height of roughly 1/3 the log diameter, about 4 inches tall. The opening tapered, narrower at the inside face, about 4 inches wide, and wider at the outside face, about 6 inches wide, creating the self-locking wedge shape of a half-dovetail. Stop blocks were nailed along one edge and on the underside. These blocks registered the jig against fixed reference points: the inside wall line, marked by a string, and the top of the course below. Once these stops were set, the jig automatically positioned itself at the correct height and offset for every log. The operational sequence was fast. Place the log on sawhorses, intended inside face up. Drop the jig so the course height stops rest on the previous course, and the side stop aligns with the interior wall line. Trace the notch outline inside the opening. Move the jig to the opposite end of the log. Trace again. Saw the shoulders. Chop out the waist. Lift the log once onto the wall. Modern and mid-20th century dovetail cabin guides showed nearly identical jigs, validating that carpenters working independently converged on this solution. The geometry was constrained by the notch itself. There were only so many ways to create a reliable template. The innovation wasn't inventing a new shape. It was recognizing that a fixed opening in a board could replace eyeball judgment and repeated test fits. Once the jig was built and the stops nailed on, every log knew where to be notched without any more measuring. The builder's skill shifted from layout to execution. Sawing and chopping became the only variables. A notebook page showed 2 columns, by eye and by board, with minutes tallied next to notch counts. The handwriting was careful, the arithmetic methodical. Someone had tracked time. For a 16 by 20 cabin with 9 courses, 36 corner notches total, the time difference was dramatic. Using conventional workflow, each notch pair took 30 to 40 minutes. Roll the log onto the wall to mark contact points by eye. Roll it back down to cut. Roll it back up to test. Roll it down again for corrections. Repeat until acceptable. Each log was fully lifted 4 to 6 times. Multiply 30 to 40 minutes by 36 notches, and the total notching time ranged from 18 to 24 hours. With a wasteboard jig, the workflow collapsed. The jig fixed geometry and location. The log stayed on sawhorses until both ends were fully marked and cut. 1 lift onto the wall, 1 check, then pinning. Forest Service preservation crew experience in modern hand tool work suggested 15 to 20 minutes per notch pair when using a proven jig with a practiced crew. Multiply 15 to 20 minutes by 36 notches, and total notching time dropped to 9 to 12 hours. The critical insight was that cutting time per notch changed only modestly. An experienced hand with a sharp saw and axe could cut a dovetail notch in 10 to 15 minutes, whether working from eyeball marks or jig tracings. What changed dramatically was handling time. Most refits disappeared. For a 3-man crew working 10 to 11 hours per day, the difference was transformative. Conventional notching required roughly 2 days of pure corner work, plus additional time for layout, log movement, and corrections. Total wall raising time of 5 or 6 days. Jig-based notching cut corner work to 1 day or less, with total wall raising time dropping to about 3 days. The ledger entry "walls up, 3 days" became mathematically reasonable only if something like a wasteboard jig was in play. 3 men working 30-plus hours over 3 days could lift and set 18 logs, cut 36 notches, and pin the structure to full height, but only if layout and corrections consumed minimal time. The work itself didn't feel different day to day. Axes still swung, saws still cut, logs still had to be muscled into place. But the ledger showed something startling. Crews using the jig lost almost no daylight to corrections. Every log dropped in once, and that made all the difference. A thin line of snowflakes blew in at knee height through a corner with oversized chinking gaps. The cabin was warm near the stove but freezing along the walls. 2 cabins of similar size, age, and materials could experience very different comfort and maintenance histories because of corner geometry. National Park Service Preservation, Brief 26 on log buildings documented typical problems. Air infiltration through poorly fitted corners, chink gaps of 1 inch or more, and recurring failures where settling and shrinkage opened joints that had never been tight to begin with. Conservation notes from historic log building collections showed that V-notches and saddle notches typically performed worse than dovetails in exposed sites, especially under asymmetric snow loads. The technical reasons were straightforward. Dovetail corners with consistent geometry produced even bearing surfaces. Weight distributed uniformly. As logs settled and shrank, the wedge shape pulled joints tighter rather than opening gaps. Poorly matched corners concentrated load at high spots, crushed fibers unevenly and opened gaps as logs moved. These gaps became primary leakage paths despite repeated chinking. Government inspectors, noting the condition of ranger cabins after years of use, described smoke infiltration, drafts at floor level, and the need for constant chink maintenance. Homesteaders remarked in journals about fighting cold despite keeping large fires. The common thread was corner failure, not catastrophic structural failure, but slow, steady air leakage that made cabins hard to heat and uncomfortable to occupy. Using modern building science principles and historical fuel consumption records, the fuel penalty for drafty corners was significant. A cabin with tight dovetail corners and modest uniform chink gaps could plausibly cut firewood consumption by a substantial fraction compared to one with wide, shifting corner openings. Estimates based on preservation data suggested differences of 20 to 30% or more in seasonal fuel use. Over a cabin's first decade, that translated to hundreds of cords of wood, weeks or months of cutting and hauling labor saved. 3 extra hours spent building a jig and cutting consistent corners could save 3 extra cords of wood over the first few winters alone. The storm didn't care how corners were cut, but the occupants did. Tight geometry meant warmer floors, less time tending the fire, reduced risk of respiratory illness from chronic cold exposure, and structural integrity that lasted decades rather than years. The difference between good enough and done right was invisible in summer. Winter made it obvious. Morning frost still coated the log pile as the first log of day one was being skidded in. The crew worked quickly, not frantically, but with the focused efficiency of men who knew exactly how many hours of good weather remained. Standard building advice would allot a week or more to reach wall height for a cabin of this size. But the ledger for this build would eventually record walls up 3 days. Reconstructing that timeline revealed how a wasteboard jig turned an improbable schedule into documented fact. Day 1. Site preparation, setting the base course on the foundation and raising the first several courses. The wasteboard jig was in continuous use from the first log. One man positioned logs on sawhorses. A second dropped the jig, traced notches, and moved to the next log. A third sawed and chopped. By day's end, 4 to 5 courses stood. Day 2. The main wall height was achieved. Division of labor became rhythmic, one marking, one cutting, one hauling, and setting. The jig eliminated layout delays. Logs that fit the first time stayed on the wall. By evening, 8 courses were up, and the structure approached final height. Day 3. Final courses, pinning joints with wooden pegs or iron drift pins, and preparation for rafters. By mid-afternoon, the walls stood complete and plumb. Notches were uniform, corners were tight. The crew could move immediately to roof framing. Cross-checking this timeline with daylight hours and realistic work pacing showed that 3 men working 10 to 11 hours per day could just barely fit the required notch count, log handling, and course setting into 3 days. But only if every log dropped in once. There was no margin for error, no time for recuts, no buffer for bad fits. Forest Service records and National Park Service examples documented rapid seasonal builds at ranger stations and remote work sites. Crews working under similar time pressure, between stock movements, before snow, or ahead of scheduled patrols, achieved comparable results. The only plausible explanation was systematic layout control. When you overlaid the ledger schedule with the notch count, there was barely enough time, unless every log dropped in once. And that was exactly what a wasteboard jig delivered. One door swung freely in February, another bound in its frame because the walls had racked. 2 cabins of similar age and exposure, built within miles of each other, experienced the same extended cold spell and heavy snow, but only one weathered it without structural distress. Weather Bureau records and monthly weather review indices documented severe cold waves across Montana and Wyoming in the late 19th century. Extended periods below 0 degrees Fahrenheit were common. Snow loads on roofs could exceed 2 feet at higher elevations. These conditions tested every aspect of cabin construction. The difference showed most clearly at the corners. Cabin A, built with hand-cut corners and uneven geometry, showed corner separation in winter photographs. Chinking forced to bridge large gaps eventually failed. The frame twisted slightly under asymmetric snow load. Doors bound, windows leaked air. Emergency braces or added blocking appeared in later photos. Cabin B, built with corners cut using consistent jig-based layout, showed minimal movement. Corner joints stayed tight as logs settled. Chink gaps remained small and uniform. The structure held plumb through the first winter and required only modest maintenance in subsequent years. Using heat loss reasoning and historic accounts of cabin comfort, the performance difference was measurable. Cabin B likely maintained a several-degree temperature advantage at floor level for the same fuel input. Occupants spent fewer hours tending the fire. Interior frost was reduced. The risk of respiratory illness from chronic cold exposure dropped. Mail carriers and rangers reporting cabin condition in winter noted which structures were tight and which required heavy chinking work or repairs to frame. Local doctors and storekeepers heard complaints about sickness tied to cold, drafty cabins. The pattern was consistent. Cabins with poor corner geometry struggled through their first winter and often required significant retrofitting by spring. Inspection notes documented the results. Corners opening requires additional chinking versus no repairs noted this season. The difference wasn't luck. It was geometry executed systematically rather than guessed at log by log. 3 feet of dry snow on the roof and 7 days below zero revealed whether corners were cut by eye or by jig. No testimony was required. The structure itself testified. A typed manuscript sat on a government desk in Washington, D.C. Building with Logs, Miscellaneous Publication number 579. The year was 1944. Clyde Fix and W. Ellis Groban were codifying decades of Forest Service log building experience into a systematic manual. By mid-20th century, log construction had shifted from folklore to technical discipline. Building with Logs emphasized consistent notch dimensions, proper log preparation, and controlled settlement. Dovetails and Broadaxes, published by the Forest Service in 2008, summarized preservation lessons for historic cabins, including detailed diagrams of notch types and their long-term behavior. These documents systematized what frontier builders had learned through experience: the importance of foundation drainage, the value of log selection, the superiority of certain notch designs in exposed sites, and the need for adequate roof overhangs. The manuals described geometry and process control, but still assumed manual layout with scribes and dividers. Specific jig examples appeared more commonly in later how-to material and log building schools. The principles, however, were embedded: repeatable layout, fixed reference faces, and systematic approaches to complex geometry. A builder reading these manuals and seeking the fastest reliable method for dovetail corners would inevitably arrive at some form of template or jig. The geometry itself demanded it. Training materials from the Civilian Conservation Corps in the 1930s showed crews learning log construction from older rangers. Photographic sequences documented standardized procedures, foundations staked and leveled, logs sized and peeled, corners laid out with consistent methods. By this era, the frontier ideal of the lone gifted builder had largely given way to team methods, checklists, and documented plans. When later manuals told builders to standardize notch dimensions and use guides, they were quietly ratifying what a few anonymous frontier carpenters had discovered with a scrapboard in the 1880s. The wasteboard jig was one example of a larger pattern. The West was built and stabilized by methodical craft and simple process aids, not improvisation alone. The myth celebrated toughness and speed. The technical record emphasized layout discipline, foundations, and consistent joinery. The structures that still stood after a century shared common traits, and none of those traits involved bravado. A modern builder clamped a shop-made dovetail jig to a squared log and started a chainsaw. The jig was steel-edged, adjustable, and commercially available, but the principle was identical to a frontier wasteboard. Let the template hold the geometry, then cut to match. In present-day log-building schools, preservation workshops, and owner-builder sites, the logic behind the wasteboard was so common it had become invisible. Current manuals and online guides explicitly taught dovetail jigs and layout templates. Preservation crews repairing historic cabins fabricated temporary jigs to match original notch profiles, confirming that consistent geometry had always underlain the best historic work. The story sticks. Layout poles and pattern boards that 19th century carpenters used for framing, roofing, and stairwork remained standard practice in modern timber framing. The principles were universal. Measure once, cut many times. Let fixed references eliminate cumulative error. Shift brainwork into tools so hands could focus on execution. Many modern owner-builders started with romantic notions of eyeballing a cabin, trusting intuition and traditional methods. Those who succeeded reliably ended up using templates, stops, and standardized procedures, exactly the tools that quiet frontier builders had used when speed and consistency mattered. The technology that cut wall notching time in half was now so ordinary it disappeared into job site clutter. Commercial jigs hung on workshop walls. Plywood templates sat in truck beds. Pattern boards for stairs and trim were standard equipment, yet each one represented the same insight. Geometry stored in wood allowed faster, more reliable work than geometry stored in the builder's head. The principle had become the baseline. What had once been a frontier adaptation of shop practice was now simply how log work was taught and executed. The innovation had succeeded so completely that it was no longer visible as innovation, just competent practice. A ledger page from the late 19th century sat in an archive, its margin note brief and unremarkable. Cabin walls complete. 3 days. Weather fair. Beside it were tallies for hay bales moved and freight hauled. The note recorded a fact without emphasis. Its implications for labor, fuel consumption, and long-term survival were immense. Faster, more reliable notching freed scarce autumn days for fuel cutting, forage securing, and livestock protection. In a climate where winter length and freight distance were fixed, those extra days could mean the difference between adequate preparation and dangerous shortfall. Tighter corners reduced drafts and maintenance, extending cabin service life and cutting long-term labor and wood consumption. Preservation reports confirmed that well-built cabins with consistent corner geometry served for decades with minimal intervention. Poorly built cabins required constant chinking repair, structural bracing, and often complete rebuilding within 10 to 15 years. The cumulative fuel savings alone justified the extra hours spent on systematic layout. A cabin that burned 20 to 30% less firewood over its first decade saved weeks or months of cutting and hauling labor. That labor could be redirected to improvements, livestock care, or simply rest, critical factors in long-term homestead or ranch viability. The same principles that enabled 3-day wall races in the 1880s and 90s eventually underpinned Forest Service and National Park Service guidance in the 20th century. Modern preservation crews repairing historic cabins followed the logic embedded in surviving structures: consistent geometry, controlled layout, repeatable processes. On a frontier where no one could change the length of winter or the distance to the railhead, control over geometry and process was one of the few levers builders actually had. A scrapboard with a trapezoidal hole wasn't dramatic technology, but it turned unpredictable corner work into controlled manufacturing. It shifted the bottleneck from skill and judgment to simple execution. The cabins that still stood in high, windy country a century later were not monuments to speed. They were monuments to a simple rule. Let a piece of wood hold the math, then cut every corner to match it. On paper, it was a scrap of board with a notch cut out. In the records, it was the difference between walls up in 3 days and no cabin standing there at all. If you value fact-grounded frontier history, where the numbers, tools, and weather tables matter as much as the stories, consider supporting the channel so we can keep digging into the actual methods that kept people housed in the American West.